Question number 9 of the PhilNITS FE afternoon portion of the exam. In this question, we are given a procedure called preorder that traverses a binary tree and outputs the value of each node by following the sequence root, left subtree, and right subtree using a stack last in first out. Each node of the binary tree is represented by a class node. The table shows the description of the class node. It's the part here. Okay, so we need to have these left and right nodes as well as this part here. We also have an info of type character, and the next part says that the node type variable holds a reference to an instance of the class node. The argument root holds a reference to the root of the binary tree, which is an instance of the class node. In the program, areas outside of the array must not be referenced. Okay, I think we need to emphasize this row here. The sequence again is root, left subtree, and right subtree, using a stack last in first out. I emphasize this row in particular because knowing the sequence and also this part, the stack last in first out, should help us solve the problem. Because if, for example, you only went with the sequence and forgot about the stack last in first out, I think you'll encounter a problem with your answer, especially when you do test the idea. Let's look at the program. Here is our preorder function, where again the sequence that we need to output is the one that we were talking about, the one with the root and the one with the, let me see if I can remember that part, root, left subtree, and right subtree. Okay, and we got the blanks here, A, B, and C. And again, to be able to at least narrow down the choices, we can look at the answer group. And here we find that for blank A, we only have two choices, 0 or -1. For blank B, it's right or left, and C, left or right. So in this case, I was able to choose the correct answer, but I think this type of question where maybe you've gotten B and C correct, but it was only letter A, the blank A, that um, was wrong, so that the whole thing was wrong for you already. And I think that happened to me in one of the previous questions. Therefore, what we need to do is to really test the idea and see whether this is indeed the correct answer. Okay, if we look at the program and I put here the answers already in the blanks. Let's see, we got the pre-order function, and again what we need to do is make sure that the sequence, the output would be root, left subtree, and right subtree, while thinking about that the stack is last in first out. Okay, here the pointer is saying that it's at 1, and the pointer at 1 is set to be the root. And then for the while loop, it's saying that if the pointer, the stack pointer, is not 0, then we go through this part here. Okay, the one inside the loop, this part. And then I think later on we can further explain why is really 0 and not -1. But for the time being, let's see what will happen once we go into the while loop. It says here that we need to pop an element from the stack. And in this case, that would already be the root. So our sequence where we need to output the root is okay. Now the next thing that we need to do is subtract 1 to the SP. Currently at 1, now 1 minus 1 now gets 0. Okay, and then the next thing that we need to do is see if there's an element to its right. And I need to emphasize too this part, not undefined. Okay, so that means that there's an element. If you forgot the not here, you only remembered or you only saw undefined, then it's likely that you'll get this wrong. But not undefined means that there's an element to its right. So the root, does it have an element to its right or not? And if it does have an element, then we have to do a +1 to our currently 0 SP, so that it's now 1. And that's why the V that right, the element to the root's right, would be at 1 now, at 1 of the stack. Previously it was the root, now it's gonna be the right element. Okay, now the next thing that we need to do is look at the element to the left of the root and see if it's not undefined, if it's there or not, if there's an element there or not. And if there's an element, then we need to make a +1. So from 1 now we go to 2 and we put the value of the element of the root, the left of the root, to the stack at 2. That's why we get something like this. Now once we've done that, we have to go back to the while loop and it's saying that SP is not 0, or is it 0? Currently it's at 2, so it's not 0, and we have to go into the loop again and see here that we have to pop an element from the stack, which is currently at left. That's why our sequence saying that left sub-tree would be the next thing to come out to pop is correct. We do a -1 to our 2, and now we're back to this part, the one to the right, and we know that it doesn't have any more elements to its right, so we don't go through this part anymore. We then see if it's left element. Does it have a left element or not? Does it exist there or not? And we know that it doesn't have any more elements, so we go back to the while loop, and because it's 1 right now, it's not 0, so we have to go into the the statements below the while loop, and that's when we popped an element from the stack, which is the right subtree. Okay, now our count from 1 is now 0. Okay, and we don't have any more elements there. We go back to the while loop and saying that is SP not 0, and we know that it's 0, so we don't need to go through this part anymore, and that ends the function. And a while ago, the alternative to 0 is -1, and if it's -1, then we'll need to go into the while loop again. But the problem would be here where are at 0, but the minimum, the stack pointer says that the minimum should be 1. The root is at 1. So I think that we don't need to go to -1 here, because the minimum, the root, is at 1. Similar with the idea that we're starting at 1 instead of 0. Okay, I think if your mind is thinking about starting at 0, then maybe you choose this one, but our root is at 1. We're starting at 1, so that's why this one is really 0. Okay, now the last in first out concept, we needed to put the right here and not the left here first, because the one that we last put in should be the one that goes out, right? So that's why the second step in the sequence is the left subtree. If we exchange these, then what will happen would be we will put the right in this position so that it goes out first. Okay, because the right would be put here, and therefore this one would be the right, and if you look at the sequence, it will be in reverse. I think many people would likely make the mistake that they see the sequence root left subtree, then it's supposed to be root left and then right. They immediately think that it's going to be like that, but what we have would be a last in first out stack. So in that sense, we need to reverse this one so that we can get the correct output. So from the initial idea that it's left and left right like that, immediately, because there's a stack last in first out, then we need to put the left after we do the right. Okay, so the sequence would be like this in the if statements. Okay, so again, what is the correct letter for our answer? It's supposed to be letter B.